From this lesson onwards, we are starting with a new chapter called Recursion, and in this particular lesson, we will try to understand some basics related to recursion. So let's get started. First, we will try to understand the definition of recursion. Then we will move on to a program which will help us to understand what recursion is all about. And then we will move on to a homework problem at the end of this lesson. Now let's dive into the content. What is the definition of recursion? Recursion is a process in which a function calls itself directly or indirectly. For example, function fun is calling itself. As you can see, this is the call to a function fun itself, right? Inside this function fun, you are calling again this function only. This is nothing but recursion. Because recursion says that it is a process in which a function calls itself directly or maybe indirectly. So here, as we can see, function fun is calling itself. Therefore, this is nothing but recursion. Now let's see this program which will help us to understand recursion. Whenever a function is called, its activation record will be maintained inside the stack, right? As recursion is no exception, therefore, here in this case also, we will consider one stack, and here we will maintain the activation records of the functions we are calling, okay? As we know, the execution starts from the main function and operating system calls the main function. Therefore, the activation record of main function will be first maintained inside the stack, right? And what does this activation record will consist of? It will consist of the locals of this function. Along with that, the parameters of this function. Also, it will consist of the return address to the caller. But here, for the sake of simplicity, we are just maintaining the local variables inside this activation record. That means n equals to 3, which is the local variable of this function, will be maintained inside this activation record, right? After this step, as you can see, here we have a printf function, and inside this printf function, we are calling the function fun. So who is the caller of this function fun? Main function is the caller of this function fun, right? And here, as we know, the value of n is 3. And in this function, we are passing n, which means we are passing value 3. And where is the definition of this function? The definition of this function is written over here. Therefore, we can say that from the main function, we are calling fun3, right? So let me maintain the activation record of this particular function inside the stack. As the value of n in this case is 3, as it is indicated over here, therefore, it will get replaced by 3. And because the activation records do consist of parameters as well, therefore, in this case, n equals to 3 will be maintained inside the activation record of this function. Now, as you can see, inside this function, the first step is to check if this condition is satisfied or not. As in this case, n is equals to 3, therefore, this n will be replaced by 3. As 3 equals to 1 is false, this will not get evaluated. As this is false, therefore the else part will get evaluated, and inside the else part we can see we have one statement, return 1 plus fun n minus 1. So you can clearly observe this is recursion because fun is calling itself, right? As here we are calling fun n minus 1, n value is equals to 3, therefore we can say that this will get replaced by 2. So from fun3, we are calling fun2, right? Therefore, now the control will transfer from fun3 to fun2, and hence the activation record of fun2 will be maintained inside the stack, but above fun3. Now fun2 is under execution, which means now the n value is equals to 2, and hence this will also get replaced by 2, right? And again inside this function, we will check this condition, is n equals to 1 or not? That means is 2 equals to 1 or not? As 2 is not equals to 1, therefore it is false, which means else part will get evaluated. And in else part, we have one statement, return 1 plus fun n minus 1. As n here in this case is 2, therefore this will get replaced by value 1 because 2 minus 1 is 1, right? Now, fun2 is the caller and fun1 is the callee, right? From fun2, we are calling fun1, which means now the control will transfer from fun2 to fun1. and the activation record of fun1 will be maintained inside the stack. This will get replaced by value 1 as n is equals to 1, and n equals to 1 will be maintained inside the activation record because n is the parameter of this function, right? Now again we check this condition. As 1 is equals to 1, which is true, therefore this part will get evaluated. Here in this case we have simply return 1, which means we are returning back to the caller. And who is the caller of fun1? Fun2, right? Which is indicated over here. Return means you are simply popping this activation record out of the stack and you're returning back to fun2, which means you're returning back to the place where you left off. And this is the place where you left off, remember? So this will get replaced by value 1, which was returned by fun1. As 1 plus 1 is equals to 2, therefore now 2 will get returned back to the caller of fun2, which is fun3. And hence, the activation record of this fun2 will get popped out of the stack. And we will return back to this particular place inside function fun3. As 2 was returned by the fun2, therefore, this will get replaced by value 2. 2 plus 1 is 3. And as because we are returning value 3, which means 3 will get returned back to the caller of fun3, which is the main function, as you can see in the stack, right? This means fun3 activation record will get popped out of the stack and value 3 will get returned back to the main function. But at which place? The place where you left off, which is this only, right? Therefore, this will get replaced by value 3 and we will simply print this value 3 on the screen. Therefore, the output of this particular program is 3. Recursion is not a rocket science. It is very simple to understand. How you're calling a function and where you will return back is what you need to understand about recursion, which can be very easily simulated with the help of stack. Now as you can see, we are returning the value back to the operating system. Therefore, this activation record of main function will also get popped out of the stack and the program is now finished. Let me explain you one more method which can be a very useful method if these type of questions will come in your examination. Drawing the stack and drawing the activation records is a very good idea, but not in the examination. When you're trying to understand the concept, then stack will be the best idea for you. But if you want to solve these questions in your examination, then the method which I'm going to tell you will be the better method. As the execution starts from the main function, and inside this main function we are calling fun3 because n is equals to 3. Therefore, let me write this particular function over here. Now as n is equals to 3 and 3 is not equals to 1, therefore this will not get evaluated, but else part will get evaluated, right? So the statement which will get evaluated, we will simply write it over here. This simply means that fun3 will evaluate return 1 plus fun2 because n is equals to 3 and 3 minus 1 is 2. That is why we are writing 2 here. Before evaluating this statement, we must know what is the value of fun2. Now fun2 will be called, right? Therefore the control will transfer from fun3 to fun2. And whatever will be evaluated by fun2, we will simply write it over here. As n is equals to 2 and 2 is not equals to 1, therefore this will not get evaluated, but else part will get evaluated. As this is the statement which will get evaluated by fun2, therefore we will write this statement over here, which is return 1 plus 1, 1. Because n is equals to 2 and 2 minus 1 is 1, we are simply writing 1 over here. Now the control transfers to fun1 and n is equals to 1 and 1 is equals to 1, which means true. Therefore, this is the statement which will get evaluated by fun1 and hence we write this statement over here, return 1. Return 1 means we are returning value 1 back to the caller, which means we are returning back to this particular place. You just simply need to mark this arrow over here and this will get replaced by value 1, right? And 1 plus 1 is 2. Therefore, we will return value 2 back to the caller, which means at this particular place, right? This will now be replaced by value 2 and 1 plus 2 is equals to 3. Now 3 will be returned back to the caller, means at this particular place, which means to the main function at this particular place, and this will get replaced by value 3, and this is our output, right? You just need to follow this sequence, and when you find out the return statement with a single value which does not consist of calling the function once again, then from that point onwards you will simply return back. And following this particular sequence is much easier as compared to the previous one. Now let's get to our homework problem. What is the output of the following C program? Here is the C program available. I have made some changes to the code which I have previously written and gave it to you as a homework problem. Now you need to determine what is the output of this particular program. Is it A, 4? Is it B, 7? Is it C, 15? Or is it D, 12? Okay friends, this is it for now. Thank you for watching this presentation.